Hydrocarbons are the compounds that contain only carbons and hydrogens. And for Article 1, we are going to focus on hydrocarbons. We can divide hydrocarbons into two categories. One is the aliphatic compounds. The other is aromatic compounds. Aliphatic compounds contains alkanes, alkenes, and alkynes. Aromatic compounds contains arenes. And some characteristics about these compounds. For alkanes, we have only single bonds. Alkenes will have one or more carbon-carbon double bond. And alkynes will have one or more carbon-carbon triple bonds. For arenes, it will contain a benzene ring, a 6-membered ring with double bonds and the single bonds alternate in the ring. So again, hydrocarbons contains only carbons and hydrogens. Next, we will take a look at the functional groups. Functional groups are structure units responsible for a given molecule's reactivity under a particular set of conditions. So, as I just showed you, CC double bond, CC triple bond, they are functional groups present in alkenes and alkynes. We will learn many functional groups which are responsible for a certain type of reactivity of the molecule. And I do not require you to memorize all these functional groups now, but I hope as we learn it, you will know the functional groups. So by the end of Article 2, you should know all the functional groups that are listed here. First, alcohols. Alcohols will have OH group as a functional group. The R here, ROH, the R here represents a group of carbons and hydrogens. So we just use that as the generic compound representation. So ROH represents alcohols. Alkyl halide contains halogens. It could be fluorine, chlorine, bromine, or iodine. Amines are the compound that contains amino group, NH2. Ethers have oxygen connect to 2 carbon atoms. Epoxide has a 3-membered ring with an oxygen in the ring. Nitrile has this cyanide group that have a CN triple bond. And the thiol has an SH group. Next, we will look at another special type of compound that is called carbonyl. The carbon-oxygen double bond is called a carbonyl group. Carbonyl-containing compounds rank among the most abundant and biological significant classes of naturally occurring substances. So the first group is called an aldehyde. Aldehyde has a hydrogen atom attached to the carbonyl functional group. Then it's the ketone. Ketone has 2 carbons attached to the carbonyl carbon. Carboxylic acid. Carboxylic acid has an OH group attached to the carbonyl carbon. the other side is another carbon. The last 4 compounds are carboxylic acid derivatives. They are all derived from carboxylic acid. Acyl chloride has a chloride directly attached to carbonyl carbon. Acid anhydride. Anhydride is a compound formed by 2 carboxylic acid with the loss of 1 water molecule. So we have carbonyl connect to an oxygen, which connect to the other carbonyl group. Ester is formed by reaction between carboxylic acid and an alcohol. So in ester, we have carbonyl connect to an oxygen to another carbon atom. Amide has the carbonyl group connect to an amino functional group. So for all these functional groups, we are going to learn them one by one. And as I said, I hope by the end of Algo 2, you will know all the structures of these compounds. So chapter 2 focuses on alkanes, the first group of hydrocarbons. Now, alkanes have the general formula of CnH2n plus 2. So that means if we have n carbon atoms, we will have 2n plus 2 hydrogen atoms present in that alkane molecules. The first 3 alkanes are methane, ethane, and propane. They contain 1, 2, and 3 carbon atoms. And you can calculate the number of hydrogens. There will be 4, and 6, and 8. The boiling point of these 3 compounds are listed here. As you can see, with the increase of carbon atoms, the boiling point will increase. And this is true for all organic compounds. When we have more carbon atoms, the boiling point will be increased. In one category. For example, in alkanes in this case. Alkanes are colorless, odorless. And regarding the structure, all carbon atoms in alkanes are sp3 hybridized. So they are in the tetrahedron shape around the carbon atoms. All the single bonds are sigma bonds. Now let's take a look at ethane more specifically. We have seen the Lewis structure of ethane. So when we say C2H6, that is the formula of ethane. And the Lewis structure, when you draw all the carbon-hydrogen bonds and the carbon-carbon bonds out, that tells you the structure of this compound. So we call this the structural formula. Sometimes if you are going to draw a big molecule with the structural formula with all these carbon-carbon bonds, carbon-hydrogen bonds, it will take a lot of space and may not be necessary. So we have another way to represent the molecule. We can group the molecules together. For example, we can put down CH3, CH3 to represent ethane molecule. It's our understanding that we have 3 hydrogens attached to the carbon, and then the 2 carbons are linked together. There are 3 hydrogens attached to the second carbon. So this structural formula is the condensed form. We call it the condensed structural formula. For propane, the 3-carbon alkane, C3H8 will be the formula. The Lewis structure with all the carbon-hydrogen-carbon-carbon bonds are the structural formula. And the CH3, CH2, CH3 will be the condensed structural formula. We don't even have to show the carbon-carbon bond. The other thing I want to mention here is carbon atoms are in the tetrahedron shape. They are not linear. So for the propane molecule, you can either draw the 3 carbon in a line, or you can turn 1 carbon down. These represent the same propane molecule. The actual structure of propane looks like this. So again, keep in mind, carbon atoms are in the tetrahedron shape. So we have a bond going in, a bond going out on each carbon atom. Alright, now for the rest of the alkanes, butane, pentane, hexane, heptane, and then octane, nonane, decane,